students, I want you to focus today on what this acronym actually means, because I have a lot of students throw this acronym into proofs and put it in the wrong part of the proof because they memorize like the letters of the acronym, but they don't understand what it actually means and why in the world we're using it. So make sure you pay attention today to what do those letters even stand for and why would we need this in geometry. Now, this theorem, CPCTC, is actually very, very common sense. You're going to be like, wait, that's all it means? That's all it stands for? But it's actually very, very useful in mathematics and proving different parts of triangles congruent. So,
is it on your list?
What does it mean? Yes, it is on your list. So we could play hangman, but we're not going to because it is already on your proofs list. But sometimes it helps to see it spelled out. So it stands for corresponding. So we said that word on the first, like the parts of the triangles that go together, that's corresponding. Corresponding parts of congruent triangles are congruent. And that's all it means. So go ahead and write that down.
Normally you'll come back with these beautiful fallbacks.
So write this down. If two triangles are congruent, then the corresponding parts of those congruent triangles are congruent. It's a lot of words. That's the last time you'll ever need to write it is today, right now in your notes. And for the rest of time, you can just abbreviate CPCTC. Now, what I want to point out is what the hypothesis of this theorem is saying. What we're assuming, what comes after the if two triangles are congruent. Well, that's why we saved this for today. You can only use CPCTC after you've proved triangles congruent. After proving congruent. You can only use it after proving congruent. So this is like the extension of what we've been learning. This is when you go beyond proving them congruent. You thought when you proved them congruent by side angle side, you were done. But there's actually an extension to it, and that's what CPCTC is. So let's see how this plays out. So, look at these two triangles. We've got ABC, we've got DEF. Our job, someone came and asked us, I need to know if B is congruent to E. And at first you're like, oh, sorry, they don't have arcs on it. No, I don't know if B is congruent to E. But now that we know how to prove the triangle's congruent, well, if the triangles match, then every part of this triangle matches every part of this triangle. So if I can first prove that the triangles match by using one of my shortcuts, then I can go further and say B is congruent to E because they're corresponding parts of congruent triangles. Let's write the answer very, very mathematically. Let's write our sentence. Is angle B congruent to angle E? So how we're going to answer that question is first, we are going to state that the triangles are congruent. So write it down. Triangle BAC is definitely congruent to triangle EDF. So you're going to make a statement, and then you're going to say why. Why are they congruent? Oh, by side angle side. So these are guilty. We're not wondering if they're congruent. They're definitely congruent by side angle side. Now we need to say therefore, and mathematicians have a symbol for the word therefore. Mathematicians actually use it in real life proofs. There's the symbol. It's like 3 dots that form a triangle. It's so cool. I used it all the time in college. Therefore, exactly. Therefore, angle B is congruent to angle E. Why? Because of our news here.
CPTC.
Yeah, CPCTC. Say it 5 times fast. CPCTC. You're going to go home thinking about that tonight. All right, so there we go. We said they're congruent, then we said why. We said what the question was asking, then we said why. And that's how you use CPCTC. You use it after you've proven the triangle is congruent. All right, let's try this one. All right, let's try this one. Is angle 1 congruent to angle 2? Those aren't vertical angles. Those aren't alternate interior angles. So we can't use any of those theorems to prove them congruent. But now we have a new tool to prove them congruent. So we're going to say triangle ABC is congruent to, let's name it in the right order because some of y'all got the order wrong on the quiz yesterday. What's the correct order? Anybody? Correct order? ABC. Thank you. ABC. Yay. What are they guilty of being congruent by? You always have to say why. Side, side, side. Therefore what? What now?
It's just a headshot with a blue background.
Therefore, angle 1 is congruent to angle 2. Why do we know they're congruent now? By what?
CPCTC.
Yay! And don't forget what you mean when you write that. When you write that, you're saying because they're corresponding parts of congruent triangles. So of course they're congruent. That's what you're saying. I think we've done enough of those. We're going to, this is a cute little poem.
It's still cool.
Good. Okay.
Put your name in it.
Now we are going to do what I promised yesterday. What I talked about yesterday is taking something away. Yesterday we gave you the hypothesis, we gave you the conclusion, you gave us the why. Now we're going to babysit and take one thing away at a time. Now I take away the conclusion. You have to give the conclusion and the why that supports it. Let's do the first two together and then I'll let you try some. The statement is point D is the midpoint of AC. Then you ask yourself, so what? So what if D was in the middle of AC? What do I know now? You can say it out loud. What do you know?
That AD is congruent to DC.
Perfect. I know I can go and add tick marks to my picture. So since I can add tick marks, those tick marks really are saying that AD is congruent to DC. And now we're back to yesterday. Now we just have to say why using a definition or a theorem. Why?
Definition of midpoint.
Yay! Oops, that's a D. Remember, the answer is in the question. Remember, the answer is in the question from that clip from Night at the Museum. So anyways, if it says midpoint in the question, you should see a midpoint in the reason why. All right, next one. Given segment BD bisects angle ABC, well, something just happened. An angle just got cut in half. So what? What do you know? Can I cheat and give them numbers? Okay, thank you for your permission. What do you know? We know angle 1 is congruent to angle 2, right? An angle got cut in half. That makes two congruent angles. Why?
Are you allowed to do that?
No, but I do that on quizzes and tests. I put numbers on there for you on the quizzes and tests to make it easier. I might not do it on the homework, but on a quiz or a test, I'll put the numbers in. Good job. I saw the answer. Definition of angle bisector. Please be careful. You can't just put definition of bisector because there's an angle one and there's a segment one, and we want to make sure we use the right one every time. Look at what's being bisected. An angle is being bisected, so make sure you put angle bisector. Let's try some more.
So then after that, we will put CPCTC.
We would not use CPCTC unless we were doing one from the homework. We'll go do a homework one before class is over, okay? I'll tell you where to use CPCTC. Not in these, not yet. Okay, given A lot of my students got this wrong first period, so I want you to private chat me what you think the conclusion is if this win. Private chat, go. Okay, I'm very passionate about this one. It's important in geometry to not skip steps. You can't assume extra things and you cannot skip steps. If someone said, tell me what perpendicular means, would you say, oh, it means congruent angles? No. No, you would not. If someone just came up to you and said, what does perpendicular mean? You would say, oh, it's two segments that intersect at a 90-degree angle. That's what perpendicular is. Two segments that intersect at a 90-degree angle. So my conclusion is that angle ADB and angle CDB are right angles. Or you can put that those angles, I'm going to cheat and put my 1 and 2 just to save time. Measure of angle 1 and the measure of angle 2 is 90 degrees. Either or. Those are the conclusions that come from perpendicular. Do I agree that those are congruent angles? Yes, I agree. But that's not the conclusion you get when you're perpendicular. Now that we know that they're right angles, our next thing later in our proof, then we could say they're congruent by the right angle congruence theorem. But you can't use right angle congruence theorem if you are given perpendicular. You're just not ready to use it yet. So the Y is definition of perpendicular, lines. That's an LI. So if you look at your sheet of paper, you'll see when it says perpendicular lines, it says two lines that intersect at 90-degree angles or intersect at right angles, either one. So that's what we want to make sure matches. All right, let's look at number 5. Given AB is congruent to BC, what can we conclude? Now this one has 2 correct answers. Someone gives you a picture of that triangle. What do you conclude? What do you say? Throw out your initial thoughts. Yeah. You could say, oh, triangle ABC is isosceles. And then the reason why, well, that's what an isosceles triangle is. That's what it is. So it's the definition of what it is. And I meant to put that there. But what else could you say if someone told you 2 sides of a triangle were congruent?
Isosceles triangle theorem.
Yes, that's the why, but what are you saying? What's the conclusion?
Angle A is congruent to angle C.
Nice. So the other thing you could conclude is if 2 sides are congruent, the angles opposite are congruent, and that's not a definition, that's the isosceles triangle theorem. So the blue goes with the blue and the green goes with the green. You can't mix them up. You can't say A is congruent to C by definition of isosceles. You can't say it's isosceles by the isosceles triangle theorem. Make sure you don't hybrid those. It's either you answer both blues or you answer both greens. Okay? Yeah.
Well, we need to put both of those on the test or just one?
Please only ever give me one answer. If there's 2 correct answers, only give me one. Because I have people on the quiz giving me 2 answers and one's right and one's wrong. And I can't mark that right even if you have the right answer. You can't give me multiple choice. You need to...
If the answer has like 2, like, if it's an A and C or something and C, because that happened on like yesterday's.
Let's look at that one from the homework that you asked about now. Now, my hypothesis is if the triangles are congruent. The triangles are already congruent. Done. Then I can prove that B is congruent to D. That's like I'm going further. I'm proving something beyond the triangles being congruent. So my reason now is this new theorem that we learned. The Y is because corresponding parts of congruent triangles are congruent. All right, let's go back to our lesson. Given AB is parallel to CD, what can we conclude? Nice. Very, very good. You make your Z. When you make your Z, you realize, oh, angle 1 is congruent to angle 2. And then you back yourself up. Why are they congruent? Why? Yay! They are congruent because the alternate interior angle theorem. Let's try some more. These are fun. Given AC is congruent to AC, AB is congruent to AD, and BAC is congruent to DAC. What can we conclude?
BCA and DCA are congruent triangles.
Very good. We can conclude the entire triangles are congruent. We have enough information to say that the triangles are congruent. And what's the reason?
Side angle side.
Side angle side theorem. Technically, it's the side angle side congruence theorem, but I'm not going to count off if you just put side angle side, okay? But it is called the side angle side congruence theorem, if you were wondering.
Miss Heather?
What's up?
On the other ones, number 7.
Yeah?
Couldn't your conclusion also be that the triangles are isosceles? That triangles are big triangles like isosceles?
Yeah, but here's what you want to happen. You want your conclusion to best match your given. What is the very best match you have? So, yes, I agree that that's isosceles, but if you said that, you are only using 1 out of the 3 of your givens, and that's not really our goal here. We want to put all of our givens together to make our conclusion, okay? So thanks for asking.
Will you count it off if we answer something like that on a quiz or something?
Probably, because that's not our goal here. Our goal is to prove triangles congruent, so we kind of want that goal to match, like I said, our evidence. Evidence gives us that. If you say it's isosceles, you didn't give me enough information.
Okay.
Yeah. Okay, so our next one had all of this information. This is another one where the conclusion is that the triangles are congruent. We have to name them in the right order. ACB is congruent to DCE, and the reason is angle side congruence theorem. Try another one. Oh, that's it. That's all we have. This homework is of utmost importance. You won't have a quiz on this on Monday. I'm going to give you a whole couple days to really let this sink in, but you will have a really, really important quiz over this on Tuesday. So make peace with this homework by Tuesday and be ready with questions after the weekend.